All right. So we're back here again, looking in the book. In the book number, practice 132. So this is from the book. I've done a lot of the workbook problems. So we'll do one in the book. So looking at this, we are going to graph this problem. So remember what I was saying before. That the first thing we learned was how to graph. We learned how to graph with this equation, with our asymptote, with our rate that we plug in, our time, our initial. The second thing we learned was creating the equation from word problems, and the hardest part of that was finding time. Okay, we asked our key question: do we have the full growth at 1 unit? And if we did, it would just be x. If it took a few more, if it got all the way to 3, it would be x over 3. If we had 2 growths by the time we got to 1, it would be 2x. Okay, we'll go over that in a second. But these are the two different things. So when I'm doing this first problem here, I'm just graphing it. I don't have to create the word problem. I don't have to create anything or create the equation from the word problem. So I go here, and I'm going to just go ahead and graph the asymptote. So I look here, and what is the asymptote? Show me on your hands. What is the asymptote for this? What is the asymptote? Asymptote is... there's nothing there. So what is it if there's nothing there? There's no C value here. So it's plus 0. And if you're taking notes and you forgot why that would be, just remember our first equation here. And it might tell you, oh, there we go. Claudia's here. All right, welcome, Claudia. We are looking in the book, practice 132. We're doing number 1, just graphing this guy. All right, it comes from this, right? That should be a C. Oh man, watch this sneakiness. Ah, beautiful. So we know that it's plus C, which is our asymptote. Since there was plus nothing, it didn't have a plus. It was just this. Because it was just this, our asymptote is 0. And that means I can go here and make my asymptote at 0. Now the word problems all have it with our C value of 0. Because of the complexity of adding an asymptote, the problems we're working on now are all going to have the asymptote here at 0. Okay. Now, there is only 2 steps, really. 3 is connecting the dots. So our second step here is to plug in x and y, and we'll plug in 0, 1, 2. Okay. Now, if I write this down and plug in 0, anything to the 0 power is what? Show me on your hands. Anything to the 0 power. Yep, I see 1. 1, 1, 1, 1. Good. All right, Charlie Milheny, thanks for the chat answer. So 2 to the 0 is 1. And then we're going to go ahead and multiply those together. We get 3. Okay. So when I plug in 0, I get 3. So I go here to 0 for x. 1, 2, 3. And that is the point 0, 3. That is the point 0, 3. Okay, let's see if everyone could do this one. I want you to go ahead and plug this one in, 3 times 2 to the first, and then do 3 times 2 to the second, plugging in 1 and 2. 1 and 2 here. So find what goes right here. Find what goes right here. What 2 values go right there? Use your calculator. It's a good time to practice with your calculator because that's in the last class where I saw everyone was making their mistakes. It was all the calculator issue. Okay, I'll give you guys nice, Kevin. I'll give you guys another 30 seconds to finish that up. Let's see what we can do. All right. Let's see. Check this out. 2 to the first power is 2. 3 times 2 is 6. Boom. All right. 2 squared is 4. Y is equal to 3 times 4 is 12. So I look here, and my units might not be great for this, but I'm going to put in for 1, 2. We already did it for 0. And when I look at this, we have 1, 2, 3, 4, 5, 6. I'm going to kind of make it a little squished. And then for 2, we are up at 12. 6, 7, 8, 9, 10, 11, 12. So we're way up here. Yeah? Whoops. All right, go ahead and take a screenshot of that one if you definitely need to have screenshots of all these. All right. All right, let's see. Okay, if you're having trouble with graphing, that we're going to do probably one more for that if we need to. Okay. All right, 6 and 12. Good job, everyone that got that. Everyone okay with plugging in, connecting the dots? Just like a dot to dot, pretty much. But make it curved. Don't make them straight lines. That would be weird. All right, let's look at number 4. Number 4, we have to create the equation first. So we're going to create the equation and then do just what we did. We're going to graph it right after. So if I look at this, a basketball tournament begins with 64 teams. So start with 64 teams. For each round, teams are paired up and play each other. Okay. At the end of each round, the losing team are eliminated, reducing the number of teams by half. Okay. So what this says is each round, it says it reduces teams by half. Half. Weird. Half. Strange. All right, let's look. We have this equation. We're going to figure out the time. Plus c is plus 0. Okay, so let's go through it. We know it starts with 64 teams, so I'm going to go ahead and put that right here. 64. And then I want to fill in the rest of this. All right. 1's a part of this. And show me on your hands, what is it going to be? Plus or minus? Plus or minus? There's one key word I wrote down. Yep. Nice, Charlie. Reduces. Reduces. Minus. And then what's my rate? It's related to 1/2. So what's 1/2 as a decimal? That's the one we use to remember this if we need to. That's going to be 0.5. Now we got our time that we're dealing with. Actually, before that, I'm going to go ahead and reduce that parentheses to get 0.5. Right? $1 minus 50 cents is 50 cents. Okay. Okay, now is the key. Now comes our key question. As long as you ask the key question, life will be, okay as far as this goes. Life will be all right. It'll be all right. All right, how about this? We're going to call these rounds because each round I'm reducing the team by half, and then this is going to be our number of teams. Okay, and here's our key question. Do we have the full decay at the first round? Thumbs up or thumbs down? Let's see what it says. Each round reduces by 1/2. So, at one round, at the first round, do we have that full decay? Yes or no? We do. Do we have more, or do we have exactly the 50% decay? We have exactly? Watch. Each round reduces by 1/2. So if we started out with 64 teams, after the first round, we're going to reduce it down to 32 teams. because it's telling you it's actually each round reduces the team by a half. So guess what goes here? Just x, regular x, because it wasn't a fraction. It wasn't like it took 5 rounds to get that. It wasn't as if it took half a round. That would be a whole number. When it is exactly here, when it's exactly what we want, right? At one, then we just have x. That's it. That's it. All right. So we have our equation. And now it's just like what we did in the last problem down here, where we just graph them by plugging them in. All right. So asymptote for all the word problems generally are going to be the x-axis. And this will be a little bit of extra credit if you remember to do this. If you label the asymptote, it'll be worth, like, an extra point or something if you're really thorough. Okay. Why would it be 2x? Or why would it be 2x? Why wouldn't it be? Okay, how about this? Because it says each round, so each one round, right? Each round. So whatever sport you play, right? Where does it say 1/2? Where does it say 1/2? Oh, I see. Okay. But look what we're talking about. Look what we're talking about. Each round, right? The number of teams reduces. Each round, it reduces teams by a half. How about if it wasn't half and it said by 50%, right? Because this is talking about the rate. It's reducing the teams by a half. So we had 64, we reduced by a half, we got 32. We have 16, we got 8, we got 4, we got 2, we got champion, right? So it's not a half. This half out here is saying how much it reduces by. It reduces by a half, okay? But it's each one round. It's one round. That's how much time it takes, right? That's how much time it takes in order to reduce by the half. Yeah, you see it now? Okay, good. This was trickier. When I wrote that out, I was like, this is going to seem like we are at half of a round. But I like that. And you showed that you got it because you knew what it would have been. If it was a half, that would have meant that half of a round, then we have our decay, and then another half we have 2 decays. That would be 2x. But the time is actually each one round. So by one round, yes, we have our full decay. So we put just a full x. Okay, I'm going to graph this kind of quicker than usual. Y is equal to 64, 0.5 to the 0. Anything to the 0 is 1, so we're going to get 64. All right. Then we have 64 times 0.5 to the first. We're going to end up 64 times 0.5. This is saying half of 64 is 32. And look, I had kind of thought that already, so I know we're on the right track. Okay. Lastly, we have y is equal to 64, 0.5 to the second. So y is equal to 64. This is going to be 0.25. But when you have 0.5 squared, you're going to get 0.25. You can think of it as 1/2 times 1/2 is 1/4. 0.25, which reduces to 16. So look, I was thinking this already. It's going to cut it in half after every round. So first round, by the first round, we're going to end up with 32. Second round, third round, fourth round, fifth round. So this is going to take 6 rounds to get our champion. To get one team, that's the winner. Okay, let's graph it. Put 64 up here. All right, so now all this chicken scratch I wrote, we're just interested in that. We've done all the work. We have our 3 points. Let's just plug them in. So we have 64. So 0, 64 is 0 for x, 64 for y. Okay. 132 is going to be halfway down, and 132, 1 for x, 32 for y. Where they meet is where your point is. 216, it's going to be halfway to that. 216. There we go. Look. Man, once you get your equation and you have your table, graphing, connecting the dots, just go right at it. All right. Give me a thumbs up, a sideways thumb, or a downward thumb. Thumbs up, sideways down? Okay, okay, okay. Good, improving, improving. Okay, thank you for the thumbs. Now, we did this one already. Tell me in the chat, does anybody need to see another one of these graphed? You caught it then? You got it? All right. Anybody in the chat? Want to see that? Okay. All right, hey, perfect. A couple people had trouble on this one. We're going to do this one, and then we'll check in to see if we're ready to dismiss some of y'all a little bit early. But we usually use the whole time. I've said that before, and we use the whole time. So, but I think this is invaluable because in class, I would not go over this many problems, but I would have the chance to walk around the class and peek over your shoulder and help you out. Okay, so I actually think this is a good use of time. And so let's keep on with it. All right, we got to graph this. And so let's go ahead and just make a graph. This one looks like it's going to be hard because we got a lot of decimals right here. And notice right now, how many decimal places? 1, 2, 3, 4, 5. So when I work out the exponent of this base, I need to keep in mind that I need to keep a lot of decimal places because then I'm going to multiply it by 800. If you cut it down to be, 1.002 or 1.003, that would probably still work. But if you cut and you reduce down, and you said, well, it's just 1, then you've negated out too many of these decimal spaces. When you start with a lot of decimals, just keep in mind, during the problem, you're going to have to keep a lot of decimals. All right, so we know that. All right, I don't need that anymore. All right, so we know that we can graph the asymptote now. Remember, here's our steps for graphing. Graph the asymptote. Plug in 3 values and connect the dots. So let's see where the asymptote is. It looks like there's no number here, no constant. Because there's no constant, I know my asymptote is on the ground floor. Y is equal to 0. Whoops, I wrote 0 as I wanted to write m. If you say it, you can't write it sometimes. All right, we got step 1 down. Now step 2 is just our basic, plugging in. And this is how you would approach it if you didn't remember how to graph any function. You can always just plug in some values, plot your points, and then you can connect your dots. Like everything. When you get to quadratics next year, the x squared quadratics, you could graph that with the table and do just fine. Okay. If you forgot any, the other tricks that make it a little easier. All right. Let's start out. Y is equal to 800 times 1.00267 times 12 times 0. So 12x, I plug in 0 for x. 12 times 0 is 0. That's going to make this entire term here equal to 1 times 800. So we're going to get 800 for this. Well, I'm going to just do that out. All this is going to be a 0 here. So it's going to be a 0. So 0, any number, positive or negative, to the 0 is 1. So we end up with 800. Okay, I'm going to let you plug in 2 by yourself, but let me do 1 alongside. 1.00267 times 12 to the first. So 12 to the first is 12. I can just write that. I know 12 times 1 is 12. And then I go in here and I need to do this first in my calculator. We did a little bit of calculator practice, right? Did we do some calculator practice on Monday? No? Then everybody get out your calculators. Get out whatever calculator you have. All right. About 20% of the mistakes are going to be, maybe even more, are going to be because of this one step. When we have, actually, this one will be easier because it is a whole number as the exponent. But when it's a fraction, we get in trouble. Okay. So we're doing this right here. Let me rewrite it so it's clear. We are plugging in 1.00267 to the 12th. So go ahead and see what you can get with that, and put it in the chat when you get your answer. So we're doing this right here. We're going to try to find the next step. So we're going to apply the exponent first. Not 12. Okay, that is that times 800. I'm seeing maybe we need to go over this. All right, your answer is going to be more than 800. It's going to be more than 800. And how do I know? Look, our b value is greater than 1, so I know it's growth. If we start with 800 and grow, we got to have more than 800. So what happened? What happened? Oh, okay. All right. Yeah, sometimes things happen. No worries. All right, if you were confused, I want you to start with me. We are going to plug in. First, we're just going to write our number that we're dealing with. We have, how do I show this without glaring on you? Don't glare. There we go. I'm going to put in 1.00267. 1.00267. Okay. All right, and then I'm going to push my exponent button. Here it's y to the x. Boom. And then I know it's the 12th exponent, so I'm going to put 12 and push equal. All right. That is the exponent applied to this base. Now we multiply 800. 826. 826. Give me a thumbs down if you did not get 826. 826? Thumbs up? Okay. Melanie in the chat, tell me what kind of calculator you have. This is where, I'm sorry, this is where it becomes a little slower with calculator work. Casio. Okay. So let me do it with Casio. Just real fast, guys. If you're waiting for us, go ahead and plug in 2. Plug in 2 for x. Instead of 0, instead of 1, plug in 2. All right, so with my Casio, I'm going to put in that number, 1.00267, right? And then all right, where can I have less glare? Right there. Okay, that's good. All right, I'm going to raise that. So Melanie, yours is going to have this as your button for the exponents. The x with the box, is that what you have? Okay, you're going to push that. You see how it has a little chevron? That tells us that we're going to put whatever the exponent is right here in that parentheses. I'm going to put 12. And then I'm going to close parentheses. I don't know if that's what you have to do, but I pushed the close parentheses because it had already given us an open parenthesis. So I just closed it using this button right here, the close parenthesis, and then equals. Okay, thanks. You don't have to close it. You put equals. You got this so far? And then look, we got this right here. Now we just have to multiply by 800. Multiply times 800. 100. Boom. Right? All right, I want you to try to figure out what happened because that was fairly straightforward. I want you to try to figure out what button. You just need to see it. Okay. All right, let's try it. Redeem ourselves with y is equal to 800, 1.00267 raised to the 12 to the times 2. So remember, I was plugging in x. It was 2 I'm plugging in here. Oh, 1, we got 826. All right, let's try to do this. I'm going to reduce it for you. /24. Okay, right. So we're not ever going to multiply the exponent with the base. With this, it's an exponent, so it has to be raised to it. Okay. Ooh, that looks good, Layla. I think you're right. Yeah, that's about what it would be. Mm-hmm. Let me do it as well. Yep. Yep. Anyone else getting it? Throw it in the chat. Nice. And you know what? Max, that's perfect. Let's round up, though, for that one. You see I was pretty close to 853? Yeah, so that one we'll round up. When we round to the whole, let's just do it. Just the whole number. We look to the decimal. If it's 5 or above, we go up. There you go. Anyone else? Nice, Claudia. Perfect. Yeah, Melanie, you got it. So let's round that to 850 what? The only reason I'm saying is if our graph has 852, we're not going to be able to show that 80 cents, right? It's not going to work. All right, who else? All right, there it is. You got it. Good, Melanie. All right, it looks like a lot of folks are getting 853. Tell me in the chat if you want me to go ahead and show on the calculator how I did that. Yeah. Marcos, hold up your calculator again. What kind of calculator do you have? Let me see it. Yep, that's that one. Boom. All right, let's look right here. Remember, it's not a fraction. It's nothing crazy. All it is an exponent of 24. So we're going to go 1.00267. We're going to raise that. So I think it's this button above the division symbol. That's our exponent symbol. Push that once. And then we got to just put 24 in there. 24. I didn't use parentheses because it's just one number, right? I would use parentheses if it was a fraction, because to show a fraction, I have to do 1 divided by 2 to make a half. But since it's just 24, I can just put it as 24, push equal. We get the 1.0660866. And then from there, we've done this now. Now multiply it by 800. All right, you get it now? You got it now? All right. Anybody else have a question? That's all calculator work. And honestly, I don't expect you to have read the manual for this thing. So if you have questions about calculators, you can always ask. Okay. Let's graph these quickly, and then we'll check in. So I'm going to put 800 right here. And 0, 800. Boom. 0 for x, 800 for y. Let's see. 826. Wow, I did it on the 8th one. No kidding. All right, so I'm going to kind of warp this a little bit. I could have put that lower. I'm just going to put this right here and label it 826. And for 2, I'm going to go ahead and put it up here and label that 853. Now, the shape of the graph is going to depend on how you scale your axes. If you decided to scale it different, your graph will look different. Okay, this is a situation where you do your best to keep the graphing. I usually keep the x-axis as just 1, 2, 3, 4, 5. I try to make it fit for the y. Okay, so just accommodate the y. Keep the x values as just 1, 2, 3, 4, 5. That'll make them more. That'll look more similar. Okay, there we go. We got a graph that is going to level out right here. Right, it's gonna go ahead and level out. All right. All right, I'm going to go ahead and stop the video.